Hello, and let's begin on pre-calculus marking period 2 progress check review. So it says for number 10, find the inverse of the given function. So the important thing to remember when you're doing inverses, you're switching the x and the y value together and then solving for y again. So we're going to say y is equal to 3 to the x minus 4. So switch them, x is equal to 3 to the y minus 4. Let's add 4 to both sides. Those cancel, so I'm left with 3 to the y equals x plus 4. And then to get rid of, in a sense, the base 3 and bring down the y, we're going to do log base 3 to both sides. Log base 3 to both sides. So that ends up giving us y is equal to log base 3 of x plus 4. And that is my inverse equation. To the next one, y equals log base 2 of x minus 3 plus 1. Switch the variables. So x is equal to log base 2 of y minus 3 plus 1. So the first thing I would do is get rid of that 1, so I get x minus 1 equals log base 2 of y minus 3. Now the next thing I'm going to do is I'm going to do base to the answer equals the inside. So 2 to the x minus 1 as the whole exponent is equal to y minus 3, and then add 3, so I get 2 to the x minus 1 plus 3 is equal to y. There's my inverse. Y equals 2 to the x minus 5 plus 7. X equals 2y minus 5 plus 7. And then subtract 7. So I get 2 to the y minus 5. Now to undo that 2 and bring down the y minus 5, we're going to do log base 2 of x minus 7 equals y minus 5. And then add 5. The important thing to remember here is that when you're adding 5, you do not add it inside the log. The log stays in itself, its own entity. So we're going to say log base 2 of x minus 7 plus 5 is equal to y. And lastly, y equals 1/3 ln of x plus 1 minus 6. So x equals 1/3 ln of x plus 1, whoops, y needs to be here, and then minus 6. I'm going to add 6 to both sides, so I get x plus 6 is equal to 1/3 ln of y plus 1. Multiply everything by 3 to get rid of that 1/3. So keep in mind that you're multiplying that quantity by 3. So that goes away, that goes away. I'm left with 3x plus 18 equals ln of y plus 1. Base to the answer equals inside. The only issue is that ln has a base e, so it's a e to the 3x plus 18 equals y plus 1, and then subtract 1, so e to the 3x plus 18 minus 1 equals y. Moving on. So it says the following points is on the terminal ray of an angle theta in the standard position. Find the value of the 6 trig functions and the angle theta for each. Okay, so we're going to write this as the following. So 4 and square root of 48. So that means it's going to be somewhere right around here. So x is going to be 4. This is going to be square root of 48. So that means that the x value is going to be equal to 4. The y value is going to be equal to square root of 48. Now I need to try to figure out what my r value is. So the way to do that, 4 squared plus square root of 48 squared is equal to r squared, right? A squared plus b squared is equal to c squared, or x squared plus y squared is equal to r squared. Now don't let this fool you, that's actually a lot easier than you think it is. So 16 plus square root of 48 squared is actually just 48 is equal to r squared. This ends up giving us 64 is equal to r squared, square root both sides, and we end up getting 8 is equal to r. Now some of you guys might think, well, what about the plus and minus piece? We don't need to worry about that. R is going to be always positive in these types of problems. So the radius here is actually going to be 8. So sine of theta is y over r, cosine of theta is x over r, tangent of theta is y over x. And then cosecant is, in a sense, the flip version of each one of these. So this would be r over y. Secant is r over x. And then cotangent. Cotangent is x over y. And maybe we'll be able to figure out the theta based around those specific values. So y over r, so that'd be square root of 48 over 8. This is going to be 4 over 8. And then this is going to end up being square root of 48 over 4. Maybe this might be kind of helpful to try to figure out what the value is of theta. And then the flip version. So 8 over square root of 48. This is going to be 8 over 4. And then this is going to be 4 over square root of 48. Now, if cosine of theta is equal to 4 over 8, that means cosine of theta is going to be equal to 1/2. Where is cosine equal to 1/2? Well, that would be actually 60 degrees, or we would say pi over 3. And since it's in the first quadrant, we don't need to worry about kind of doing any other types of weird types of angles. Next one. So negative and then positive, so it's going to be right here. So this is going to be square root of 3. This is going to be 1. So 1 squared plus square root of 3 squared is going to be equal to r squared. 1 plus 3 is equal to r squared, so that gives me 4. 4 is equal to r squared. R is going to be equal to 2. So x is equal to negative square root of 3. Y is equal to 1, and then r is equal to 2. So sine of theta, y over r, so that's going to be 1/2. Cosine of theta is going to be negative square root of 3 over 2. And then tangent of theta is going to be y over x. So it's going to be 1 over negative root 3. Cosecant of theta is going to be just 2. Secant of theta is going to be 2 over negative root 3. Sorry if this is a little crammed. And then cotangent of theta is going to be equal to negative root 3. And since when is sine going to be equal to 1/2? That would normally be 30 degrees, but since we're in the second quadrant, that means that we're going to have actually 30 degrees right here. So it would actually be theta is going to be equal to 150 degrees, or we can say that that's going to be 2 pi, nope, not 2 pi, 5 pi over 6. All right, last one. So that's going to be actually right here. So root 18, negative, that's going to be that point. So square root of 18 squared plus negative square root of 18 squared is equal to r squared. By the way, keep in mind that when you do a negative times a negative, that will always equal to positive. So that'll be 18 plus 18 is equal to r squared. So that'll be 36 is equal to r squared. And r is going to be equal to 6. So x square root of 18, y negative square root of 18, r 6. So sine of theta, y over r, negative root 18 over 6. Cosine of theta is going to be x over r, so that'd be square root of 18 over 6. And then tangent of theta is going to be negative square root of 18 over square root of 18, which is actually just negative 1, which is interesting. Okay, cosecant of theta is going to be negative 6 over square root of 18. Secant of theta is going to be 6 over square root of 18. And then cotangent of theta is actually still going to be negative 1. So when is tangent negative 1? Well, that would yield a 45 degrees. But since it's also in the fourth quadrant, that would mean that it's going to be right here, 45 degrees. So we're going to go all the way around. So it's going to be 315, or 7 pi over 4 is going to be your answer for theta. Okay, moving on. So evaluate each specific trig function. We've been doing this a whole bunch of times, so this is one of those things that you can look back at your notes. I'm just going to try and knock them out pretty quickly. If you need any help, please feel free to comment below or comment on my Discord. So sine of 30 is going to be 1/2. Pretty straightforward because it's also in the first quadrant. 2 pi over 3 is really saying 60 degrees, also in the second quadrant, 60 degrees. So cosine is actually going to be 1/2, but since all students take calc, it's in the second quadrant, it's going to be negative for cosine. Tangent, which means that it's going to be right here at this specific location, pi, which is also 180 degrees, that's going to be 0. Also keep in mind that if this is -1 comma 0, right, it is y over x, so that would be 0 over -1, which would still end up giving us 0. Cosine of -225, that's actually going to end up being right here. Reference angle is going to be 45 degrees. So cosine of 45 is going to be √2 over 2. But since it's in the second quadrant, it will be negative. Over here, negative 3 pi over 2. So that's actually going to end up right here in this location, right at that specific point. And this is going to actually just be not -1, but +1. Normally it would be the y value here. So the y value here is going to be 1. Tangent of 315, that's going to be in this quadrant. Reference angle is going to be 45 degrees. So tangent of 45 degrees is going to be 1. But since it's in the fourth quadrant, it will be negative. Also think about the slope of that specific line, which is negative. Over here, √2 over 2, but you're doing it backwards. So we're saying sine of some value, theta, is going to be equal to √2 over 2. So that's going to be 45 degrees, or we could say pi over 4. When is cosine equal to -1? Right, so if we think about each part of the quadrants, so when is cosine of theta equal to -1? So where is the x value, in a sense, going to be negative? And right there, that specific value, so it will be pi, or also 180 degrees. And then tangent, negative. We also have to remember about the principal values. Tangent is going to be from -90 to 90, or negative pi over 2 to pi over 2. So this value is, in a sense, relating to 30 degrees, but it's going to be negative since it's going to be in this specific quadrant. So negative 30 degrees is going to be your answer, or we can also say negative pi over 6. Okay, so inverse of tangent of 0, that would actually be 0. So when is cosine equal to 0? That would actually be 1. When is sine going to be equal to √3 over 2? That would be 60 degrees. So tangent of 60 degrees is just going to be square root of 3. And tangent of 3 pi over 4, which is going to be -1. And then inverse sine of -1. So where is sine -1? Also known as the y value going to be equal to -1. So here, 0, -1. So this would be, normally it would be 3 pi over 2. But since most of the time we end up doing, dealing with the principal values, that's going to be from -90 to 90, or negative pi over 2 to pi over 2. So this is actually going to be, this value is actually going to be negative pi over 2, or -90 degrees. Either one would be fine. I even would probably give you most of the credit if you ended up having 3 pi over 2. Okay, I'm probably going to finish up these graphs and then save the last 2 pages for the next video. So this will be a 3-part series. Okay, so sine, remember we kind of make a table for ourselves, x and y, so 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So sine it goes 0, 1, 0, -1, 0. I'm going to make 1 here. I'm going to make -1 here. I'm going to go pi over 2, pi, 3 pi over 2, and then 2 pi. So 0, 1, 0, -1, 0. Remember to kind of continue the curve. Don't make it too steep in terms of sharpness, kind of for the high points and the low points. The amplitude is 1, the period is 2 pi, and the midline is going to be y is equal to 0. Remember to keep in mind that the midline needs to be y equals, because we are talking about a line, not just a value. And then cosine is exactly kind of the same thing. X and y, 0, pi over 2, pi, 3 pi over 2, and then 2 pi, but this starts at 1, 0, negative 1, 0, 1. So 1, negative 1, pi over 2, pi, 3 pi over 2, and then 2 pi. So 1, 0, negative 1, 0, 1. Make sure you curve your graph, and make sure you also include your arrows too. Amplitude is still 1, period is 2 pi, and the midline is y is equal to 0. Remember, period means that when does it complete one full rotation or one cycle, and that completes it in 2 pi. The amplitude refers to if I have some type of middle line, which is known as my midline, what is the distance from the midline to the highest point, or from the lowest point to the midline? So this is my amplitude. And in this case, in both the case with sine, that was actually also 1. All right, thank you for watching, and there will be one more video finishing up the rest of this packet. Thanks for watching.